Hello again, everyone. The last time that we got together, we talked about some of our special right triangle rules. We had started out with our 45, 45, 90 special triangle, our isosceles right triangle. Today, we're going to be talking about our 30, 60, 90, our second set of special right triangle rules. So, special note here is that this rule only works on triangles with angle measures of 30, 60, and 90 degrees. So, before we can start applying this rule, we do have to make sure that we are looking at a triangle that has a 30-degree angle, a 60-degree angle, and a 90-degree angle in it. We cannot assume things. If we don't know for a certain fact that we are looking at this type of a triangle, we cannot apply this rule. Okay, same to be said for the 45, 45, 90. So where does this rule stem from? It comes off of an equilateral triangle. With equilateral triangles, that we know that we're looking at 60 degrees in each one of our angles. And then we know that all the sides are the exact same. So if I take my equilateral triangle, I draw up an altitude down the middle. If it's an altitude, then we know it would create a 90-degree angle. And then also this angle up top here, that was 60 degrees to start with, just got split in half. So it's actually equal to 30 degrees. So now we know for a certain fact that we are looking at a 30, 60, 90 special right triangle. So the rules associated with this triangle, let's just say that this side length has a length of 2x. Well, when we took this altitude and split our side length down the center, now this length down here will have a length of just x. It would be half the length of the hypotenuse, or half the length of the original side. If we do a Pythagorean theorem a whole bunch of times, we get to the rule that this longer side length here, this altitude in this scenario, directly across the 60 degrees, that side length is going to be the exact same length as our short side, but it's actually radically 3 times larger. So we have our short leg, we call x, our hypotenuse, which is twice as long, or 2x, and our long leg, the side opposite from the 60 degree, is radical 3 times larger than our short side. So this rule is a little bit more to remember than with our special right triangle, the 45, 45, 90, but we can still do it. Let's go through our first example. Start you off easy. Let's say that our short leg here has a length of 5. According to our rule, our hypotenuse is going to be twice as large. And then our long leg is going to be radically 3 times larger than our short side. Short side is 5, and our long leg is going to be 5 times the square root of 3. In example number 2, let's say now I give you the hypotenuse. Let's say your hypotenuse. Well, our short leg is the easiest one to get first, the side opposite of 30 degrees. That's going to be that has a length of 6. And again, our long leg is going to be radical 3 times larger than our short leg. Our short leg is x, then our long leg will be 6 times the square root of 3. Let's up the ante a little bit on the next one. Let's say that I give you the long leg at a length of 7. Now, the long leg is supposed to be whatever the short is times the square root of 3. So if 7 is supposed to be equal to the short leg times the square root of 3, in order to solve for the short leg, we would have to divide by the square root of 3. So our short leg actually has the length 7 over the square root of 3. But just like we talked about in our last video, we can't leave our answers like this. We actually have to rationalize. So final answer is that our short leg has a length of 7 times the square root of 3 over 3. Our hypotenuse is going to be twice as long. So we're just going to take our 7 and we're going to multiply that by 2. So that gives us 14 times the square root of 3 over 3. All right, so that's our examples for our special right triangle, or 30, 60, 90. So please go ahead and try the examples now in your Google Classroom and let me know if you have any questions. Thank you for watching.